Take a breath, not a nervous one, not the kind of breath you take before a meeting or before you check your phone or before the world demands something from you again. Take a slow, deliberate breath, the kind you take when you step outside on a cold, clear night and look up at the sky and feel, just for a second, absolutely tiny. That feeling of teeniness, we're going to lean into it tonight. Because one of the most counterintuitive discoveries you can make about the universe is this: the bigger it gets, the more relaxed you feel. The more ancient and vast and incomprehensible it becomes, the more your problems, your deadlines, your arguments, your anxieties, gently, quietly dissolve. This isn't nihilism. We're not here to tell you nothing matters. We're here to tell you something far more interesting. Almost everything you worry about is, cosmically speaking, a rounding error. And that is the most freeing thing imaginable. For the next hour and a half, we're going to travel across the universe together. We'll visit places no human has ever gone, meet phenomena that have no human equivalent, and sit with ideas that have been soothing philosophers, poets, and sleepless people for as long as there have been stars to look at. And the further we travel, the lighter you'll feel. So get comfortable. Dim the lights if you want. This is not a race. This is not a test. This is just you and the universe and a little bit of time. Let's begin. Here is the first fact, and it might be the most important one we cover tonight. The atoms in your body are, many of them, roughly 13 billion years old. Not your body. Your body is young. But the matter your body is made of, the carbon in your cells, the iron in your blood, the calcium in your bones, the oxygen filling your lungs right now, that matter was forged inside stars that lived and died before our sun even existed, before our solar system, before Earth was a thought in the universe's mind. Let's slow down and really sit with that. About 13.8 billion years ago, the universe began, or at least began in the form we can comprehend, in a hot, dense state that has been expanding ever since. In the very first few minutes of the universe's existence, hydrogen and helium were formed. That's almost all there was. A vast, spreading cloud of the two simplest elements, with a tiny trace of lithium mixed in. For hundreds of millions of years, that was it. The universe was dark and cold and full of gas. Then, slowly, gravity did what gravity does. It pulled gas together. Clumps formed. Clumps grew. And eventually, when enough hydrogen packed tightly enough together, something ignited. The first stars were born. These first stars were enormous, far larger than our sun. They burned hot and fast, and in their cores, they performed a kind of alchemy that the universe had never seen before. Hydrogen fused into helium. Helium fused into carbon. Carbon into oxygen, neon, silicon. And in the most massive stars, in their final moments, silicon fused into iron. And then those stars exploded. In a supernova, one of the most violent events in the known universe, these ancient stars scattered their guts across space. All that carbon, all that oxygen, all that iron, sent spinning outward into the dark, seeding the galaxy with the ingredients for everything that would come next. Clouds of this enriched gas collapsed into new stars. Around those stars, the leftover material formed planets. And on at least one of those planets, in at least one corner of at least one galaxy, those ancient atoms assembled themselves, over billions of years of chemistry and geology and biology, into something that could breathe. Into you. The iron in your hemoglobin, the stuff that makes your blood red, was made in a dying star. The calcium in your teeth was forged in stellar fires. The carbon at the very core of every cell in your body was once part of a star that no longer exists, in a sky that no one was around to see. You are, in the most literal sense, stardust. The physicist and author Carl Sagan said it simply and beautifully. The nitrogen in our DNA, the calcium in our teeth, the iron in our blood, The carbon in our apple pies were made in the interiors of collapsing stars. We are made of star stuff. Neil deGrasse Tyson, in his own version of the same idea, went further. We are not just in the universe. The universe is in us. Every element heavier than hydrogen and helium in your body was produced by stellar nucleosynthesis, the nuclear furnaces of stars. You are a walking, breathing, thinking product of cosmic alchemy. Now here's the relaxing part of that, and it's subtle, so stay with me. There is nothing you can do to be less connected to the universe than you already are. You didn't earn your place in the cosmos. You didn't have to apply for it. The universe made you out of itself. Every atom in your body has been on a 13 billion-year journey to be right here, right now, reading these words. The universe spent billions of years making stars just so that you could exist. That's not pressure. That's invitation. You belong here. Not because you're special, but because you're made of the same stuff as everything else, and everything else is extraordinary. Part 2. The universe is almost entirely empty, and that's wonderful. Here is a fact that sounds alarming, but is actually deeply soothing. The universe is, by volume, almost completely nothing. Not mostly empty, in the way a stadium is mostly empty between events. Not mostly empty, in the way your refrigerator is mostly empty on the last day before groceries. We're talking about a level of emptiness so extreme that it makes the word empty feel almost inadequate. Let's start small, at the atomic level. You might remember from school that an atom is made of a nucleus surrounded by electrons. What they probably didn't emphasize is the scale of the space between them. If an atom were the size of a cathedral, the nucleus would be the size of a fly buzzing around somewhere in the middle. Everything else, the vast interior of that cathedral, is empty space. Your body, which feels very solid and definitely there, is almost entirely vacuum. If you removed all the empty space from all the atoms and all the humans on Earth, every single person who has ever lived could fit into something the size of a sugar cube. But let's go bigger. The distance between Earth and the Sun is about 93 million miles. That's already incomprehensible. If you drove a car at highway speed without stopping, it would take you about 170 years to get there. But the space between here and the Sun is essentially nothing. It's a void punctuated by some solar wind and a handful of wayward asteroids. Go further. The nearest star to our Sun, Proxima Centauri, is about 4.24 light-years away. 1 light-year is about 5.88 trillion miles. To travel to Proxima Centauri in that same highway speed car, you'd need roughly 50 million years. And the space between our Sun and that star? Almost completely empty. The occasional hydrogen atom drifting alone in the dark. That's it. And between galaxies? Between those great islands of stars and gas and dust that we see in telescope images? The voids are almost impossible to comprehend. There are regions of the universe called cosmic voids, supervoids, that are hundreds of millions of light-years across and contain almost nothing, not even dark matter, just space. Now, why is this relaxing? Because here you are, in all that emptiness, on a small rocky planet, wrapped in a thin shell of breathable air, which is itself an almost miraculous coincidence, reading these words and thinking thoughts. The universe didn't have to make you. It didn't have to make anything. It certainly didn't have to make planets, or atmospheres, or oceans, or life. But it did. In all that nothing, something gathered, and warmed, and organized itself into extraordinary complexity. That's you. That's everyone you've ever loved. That's every meal you've ever enjoyed, every song you've ever felt in your chest, every conversation that changed how you see the world. In a universe of almost perfect emptiness, the fact that anything exists, let alone something as strange and rich as human experience, is a kind of quiet miracle. And there's another way to read the emptiness, as peace. The universe doesn't fill itself up just for the sake of filling. It's not anxious about all that space. The void is not a problem to be solved. It just is, vast and quiet and patient. In Eastern philosophical traditions, emptiness is sometimes seen not as absence, but as potential. The space in a cup is what makes the cup useful. The pause between notes is what makes music music. The silence inside a word is what gives the word its shape. The universe's emptiness is something like that. It is the context in which everything meaningful happens. Without the vast dark between galaxies, there would be no way to see the light of individual stars. Without the empty space inside atoms, chemistry would be impossible. Without the vacuum of space, the Earth would not be the quiet, protected place it is. Emptiness, in the universe, is not nothing. It is the ground of everything. And maybe that's something to carry into your days. The idea that the quiet spaces, the pauses, the unscheduled moments, the times you're not producing or achieving or being useful, are not wasted. They are the context in which your life takes shape. They are the space the universe gave you to simply be. Part 3. Time is stranger and softer than you think. Let's talk about time, because how we think about time has a lot to do with how anxious we feel. Most of us experience time as a relentless forward march. The clock is always ticking. Deadlines accumulate. You're always a little bit behind, a little bit late, always running out of it. But the universe doesn't experience time that way. And once you understand how the universe actually treats time, you might find that your relationship with it shifts. Here's the first time fact. Time passes at different rates depending on gravity and speed. This isn't philosophy. It's physics, and it's been experimentally confirmed. Einstein's theory of relativity tells us that time ticks more slowly near massive objects, like Earth's surface, than it does farther out in space. And time also slows down for objects moving at high speeds. This has practical consequences. The clocks on GPS satellites, orbiting the Earth far from its gravitational center, run slightly faster than clocks on the ground. Engineers have to correct for this every day, or your phone's maps would drift by miles within hours. What this means, in the most mind-bending sense, is that there is no single now that applies to the whole universe. Someone on the other side of the galaxy isn't experiencing the same moment as you. When you look at a star, you're seeing it as it was hundreds, thousands, or millions of years ago, because that's how long the light took to reach you. Some of the stars you see on a clear night might not even exist anymore. They burned out centuries ago, but their light is still traveling toward us, still arriving, still crossing the dark. You are, in a very literal sense, always looking into the past when you look at the sky. Here's another way time gets strange. The universe is so old that our entire human story is a vanishingly thin sliver of it. The universe is about 13.8 billion years old. Earth is about 4.5 billion years old. Life on Earth is about 3.5 billion years old. Anatomically, modern humans have existed for perhaps 300,000 years. Civilization, agriculture, cities, writing, is about 10,000 years old. If you compress the entire age of the universe into a single calendar year, human civilization would appear in the last few seconds of December 31st. And your life? Your individual, precious, irreplaceable life? It would be a fraction of a second. Now, some people hear that and feel small and panicked, but I want to offer a different way of hearing it. Every second of your life is cosmically rare. The universe is 13.8 billion years old, and you are alive right now, in this sliver, in this moment. You don't have to justify that with productivity or achievement. The universe spent 13.8 billion years getting to the point where you could simply exist, and that is already remarkable. There's also something soothing about the deep time that came before us. Before humans, before mammals, before multicellular life, the universe just was. Stars formed and died in silence. Galaxies spiraled without anyone to name them. The whole grand cosmic drama unfolded without anyone watching, without anyone grading it, without it meaning anything in particular. It just was. And here's the secret hidden in that. The universe was fine before you worried about it. It'll be fine after, too. Whatever you're carrying right now, that tension in your shoulders, that loop of anxious thought, it's real to you, and it matters to you, and you're allowed to feel it. But it is also, in the grandest sense, a tiny flicker in an incomprehensibly long story. That story doesn't need you to solve it. It's already being told. Let's spend a little more time with deep time, because I think it holds more comfort than we usually allow it to. There's a concept in geology called deep time, the recognition that Earth's history is so long that human intuition simply cannot grasp it in any meaningful way. The geologist John McPhee, writing about this, described the difficulty of truly feeling geological time as opposed to simply knowing it intellectually. He suggested imagining the history of the Earth as your arms spread wide, and someone taking a single stroke of a nail file across the tip of your middle finger. That single stroke erases all of human history. We can know these facts. We can say them. What's harder, and what takes a kind of deliberate, meditative practice, is to feel them, to let them actually land in the body. Because when they do land, when you actually feel, viscerally, how long the Earth existed before humans arrived, how many sunrises fell on empty continents before anything looked up at them, how many rainstorms fell into oceans that no sailor ever crossed, something relaxes. Some knot in the chest loosens a little. The urgency of your moment, the pressure of your particular slice of time, softens. Not because it doesn't matter, but because it is one expression of something so much larger and longer than you could ever hold in your mind. Geology has its own version of relaxation therapy. There's an ancient Precambrian rock formation in the Grand Canyon called the Vishnu Schist, dark, almost black, twisted rock at the very bottom of the canyon walls, that is nearly 2 billion years old. 2 billion. Those rocks were already old when the first complex animal life appeared on Earth. When you stand at the canyon rim and look down at them, you're looking at something that has quietly existed through everything, through the rise and fall of every species you've ever heard of, through extinctions and ice ages and mountain building events, through everything. And those rocks are not anxious. That's not an argument for becoming a rock. It's an invitation to borrow, just briefly, some of that ancient patience, to let the weight of your concerns be, just for a moment, proportionate to the weight of everything else. Time, in the largest sense, is not your enemy. It's the medium in which all stories unfold, including yours. Part 4. The universe is expanding, and so can you. Here's a fact that took astronomers completely by surprise, and that still kind of blows minds whenever you really think about it. The universe is not only expanding, it's expanding faster and faster. In 1929, Edwin Hubble confirmed that distant galaxies are moving away from us, and that the farther away they are, the faster they're receding. The universe has been expanding since the Big Bang. That's not shocking. What was shocking was the discovery in 1998, which earned its discoverers the Nobel Prize in Physics, that the expansion of the universe is accelerating. Something is pushing the universe apart, faster and faster. We don't know exactly what it is. We call it dark energy, which is really just a polite way of saying the thing we can't see or measure directly, but that definitely seems to be there. Dark energy makes up roughly 68% of the total energy content of the universe. The other 27% is dark matter, also invisible, also not fully understood, but detectable through its gravitational effects. It's what keeps galaxies from flying apart. It's a kind of cosmic scaffolding, which leaves about 5% for everything we can see and touch and measure directly. All the stars, all the planets, all the gas, all the dust, all the life. Every atom we've ever studied, every molecule we've ever observed, it all adds up to roughly 5% of everything that exists. We are, in a sense, the visible fringe of a largely invisible cosmos. That is humbling. And it's also, I think, deeply relaxing, because it means the universe contains vast oceans of mystery. We are nowhere near the end of understanding. The scientists who study dark energy and dark matter are not frustrated people. They are people at the frontier of a genuinely strange and wonderful problem that may take centuries to fully understand. The universe doesn't give up its secrets easily. It holds them patiently, letting us discover them in our own time. There's a metaphor here for the problems in your own life. Some things don't resolve quickly. Some questions don't have neat answers. Some processes, healing, growing, understanding, take their own time and cannot be rushed. The universe, in its slow and patient expansion, in its willingness to simply be mysterious, is modeling something we could all benefit from. Not everything needs to be solved today. Not everything needs to be understood. Sometimes the right thing to do is simply to keep going, keep looking, keep expanding, and trust that more will become clear with time. Part 5. Stars are born in clouds called nebulae, and they're breathtaking. Close your eyes and picture this with me. Actually, don't close your eyes, you're reading. But slow down. Picture it. Somewhere in our galaxy right now, there is a vast, drifting cloud of gas and dust. It might be light years across. It's cold, only a few degrees above absolute zero. From a distance, it might look like nothing, a dark smudge against the stars, or perhaps a faint glow if there's a hot star nearby to illuminate it. But inside that cloud, over millions of years, something is happening. Gravity is doing its patient work. Small fluctuations in density, places where there's just slightly more gas than elsewhere, begin to pull on their neighbors. Slowly, almost imperceptibly at first, regions of the cloud begin to condense. They contract. As they contract, they heat up. Pressure builds. And over millions of years, those regions grow denser and hotter and smaller. Until, one day, the temperature and pressure at the center become so extreme that hydrogen nuclei are forced together. They fuse. And in that fusion, energy is released. A star ignites. In some of these nebulae, thousands of stars ignite, all within the same drifting cloud. The Orion Nebula, visible to the naked eye as the fuzzy star in the middle of Orion's sword, is a stellar nursery. Right now, inside it, stars are being born. If you look at that fuzzy patch on a clear night, you are looking at creation. The leftover gas and dust around newly formed stars often coalesce into protoplanetary disks, flat spinning structures that eventually, over millions of years, aggregate into planets, moons, asteroids, perhaps eventually life. Every solar system in the galaxy has a story that starts in a cloud. Our own solar system formed about 4.6 billion years ago from just such a nebula. The cloud that became our sun and all its planets was probably triggered to collapse by the shockwave from a nearby supernova. A dying star essentially gave birth to our solar system. The cycle is complete. Stars are born, they live, they die, and in their death, they seed the clouds that become the next generation of stars. This cycle has been running for billions of years. It ran before our solar system existed. It will run for billions of years after the last human has gone. And it is, in every sense of the word, a kind of breathing. The cosmos breathes slowly, one breath every billion years or so, but it breathes. There are currently about 10 stellar nurseries visible with a backyard telescope from the northern hemisphere. The Orion Nebula, the Eagle Nebula, home of the famous pillars of creation, vast columns of gas and dust where new stars are actively forming. Photographed by the Hubble Space Telescope in 1995 in an image that became one of the most iconic in astronomical history. The Lagoon Nebula, glowing reddish-pink with the light of hydrogen gas excited by the radiation of young hot stars. These are not illustrations. These are not simulations. These things are happening right now, at this very moment, in the galaxy we live in. Stars are being born. Planets are forming. The raw ingredients of solar systems are coalescing in clouds of gas that our great-great-great-grandchildren might someday name and visit. And the relaxing thing to hold on to here is this. The universe is not running out of stars. Not even close. The Milky Way alone has somewhere between 100 and 400 billion stars. And there are estimated to be 2 trillion galaxies in the observable universe. The stars you see at night are just the local neighborhood. The cosmos is full of light we can't even see from here. New stars are being born right now, in clouds so far away that their light won't reach us for millions of years. When it does, humans might not exist in the same form, or they might be living on other worlds, or they might be something we can't imagine. The universe is not winding down. It is still, in many ways, very much in the middle of becoming. Part 6. The sun is extraordinary and completely ordinary. Our sun is magnificent. It is an enormous, churning sphere of plasma 864,000 miles in diameter, so wide that you could fit over 1 million Earths inside it. It converts about 600 million tons of hydrogen into helium every second through nuclear fusion, releasing energy that crosses 93 million miles of space, and 8 minutes later, warms your face. It has been doing this for about 4.6 billion years. It will continue to do this for roughly another 5 billion years. Every day, the sun rises. Every day, it provides the energy that drives our weather, our oceans, our food supply, and ultimately our lives. It is the engine of almost all life on Earth. Without it, this planet would be a frozen rock in the dark. And here's the comforting part. Our sun is completely, totally, wonderfully ordinary. In the stellar census of the Milky Way, our sun is a G-type main sequence star, sometimes called a yellow dwarf, though it's actually closer to white. It is about average in size, average in temperature, average in brightness. In the vast spectrum of stellar types, from tiny dim red dwarfs to blazing blue giants, our sun is right in the middle. This is extremely good news. The most common stars in the universe, red dwarfs, are energetically unstable in ways that might make life difficult. The most massive stars burn out in millions of years, not billions, giving life little time to get started. Our sun, in its comfortable mediocrity, burns steadily and reliably, giving complex chemistry and biology billions of years to unfold. The fact that our sun is unremarkable turns out to be one of the most remarkable things about it. There's a lesson in that. The things in your life that feel unremarkable, the steady relationships, the reliable rhythms, the quiet, ordinary days, are often the things making everything else possible. The extraordinary tends to get the attention, but it's often the ordinary, the consistent, the reliably warm, that sustains life. Part 7. Voyager 1 is still out there, and that's beautiful. In 1977, nearly 50 years ago, NASA launched 2 spacecraft on a grand tour of the outer solar system. Voyager 1 and Voyager 2 flew past Jupiter, Saturn, and then diverged. Voyager 2 continued to Uranus and Neptune, while Voyager 1 used Saturn's gravity to slingshot northward out of the solar plane. Voyager 1 is now the farthest human-made object from Earth. As of today, it is more than 23 billion kilometers away, so far that a signal traveling at the speed of light takes over 22 hours to reach it. And yet, it still phones home. Scientists at NASA's Jet Propulsion Laboratory still communicate with it regularly, receiving data from its instruments, still functioning after nearly 50 years in space. It carries, strapped to its side, a golden record, a phonograph disc plated in gold, containing sounds and images from Earth. Greetings in 55 languages. Music from around the world, including Bach, Beethoven, Louis Armstrong, and a Peruvian wedding song. Sounds of rain, surf, wind. The sound of a mother's first words to her newborn. Mathematical and scientific diagrams explaining Earth's location in the galaxy. It was assembled and sent into the dark with one hope, that someday someone else might find it. Voyager 1 will not reach another star for tens of thousands of years. And even then, it won't exactly reach it. It will drift past at an immense distance. But it's out there, right now, while you're reading this, gliding through interstellar space in near-perfect silence, carrying music and voices and greetings from a small blue planet it left behind in 1977. The golden record contains a spoken greeting. Hello from the children of planet Earth. Carl Sagan, who was central to the creation of the record, wrote that it was a bottle sent into the cosmic ocean. A gesture, not a certainty. An act of optimism so profound it makes the heart ache. And that's what makes it relaxing. Not that Voyager will find anyone. Maybe it won't. But the act itself, the act of reaching out across the dark with music and greetings and hope, says something essential about what we are. We are a species that looks at the incomprehensible void and decides to wave hello. That's not small. That's extraordinary. Part 8. The Cosmic Calendar and the Dignity of Now. Let's do a thought experiment that has brought comfort to a lot of people. Imagine the entire history of the universe, 13.8 billion years, compressed into a single calendar year. January 1st is the Big Bang. December 31st at midnight is right now. In this cosmic calendar, the first stars ignite in January. The Milky Way forms in March. Our solar system forms in September. Earth forms in mid-September. Life appears on Earth in late September. The first multicellular life appears in December, around the 5th. The first fish appear around December 19th. Dinosaurs appear on December 25th and go extinct on December 29th. The entire reign of the dinosaurs, 165 million years, fits into just 4 days of our cosmic calendar. Anatomically modern humans appear on December 31st at around 11:48 p.m. All of recorded human history, everything we call civilization, every empire and religion and philosophy and scientific revolution and war and artistic movement, takes place in the last 10 seconds of December 31st. Every human you've ever heard of, every event in every history book, every technological achievement, every cultural renaissance, 10 seconds. Now, here you are, in those 10 seconds, worrying about your 10-second problems. And I don't say that dismissively. Your problems are real. Your pain is real. Your life is real and it matters. But there is something deeply, genuinely peaceful about putting it in this context. You exist in the most recently evolved, most cognitively complex, most culturally rich 10 seconds the universe has ever produced. You have language and music and mathematics and art and the ability to understand that you're living in the last 10 seconds of a cosmic calendar. That's not nothing. That's an astonishing place to be. Whatever you're facing, whatever difficulty or fear or uncertainty, it is happening inside a moment so brief that the cosmos would barely register it. And yet somehow, inside that vanishingly brief moment, you are here, conscious, curious, alive. The cosmos has never produced anything quite like you before, and it never will again. Part 9, The Pale Blue. On February 14th, 1990, Valentine's Day, NASA commanded Voyager 1, then about 6 billion kilometers from Earth, to turn its camera around and look back. What it photographed changed how a lot of people think about their place in the universe. Earth, from that distance, appeared as a tiny speck of light, smaller than a pixel, caught in one of the camera's scattered light rays. A pale blue dot. Carl Sagan wrote about this photograph in a way that has resonated with people ever since. He described every human who ever lived, every king and peasant, every inventor and explorer, every saint and sinner, every mother and child, all existing on that mote of dust suspended in a sunbeam. He spoke of the rivers of blood spilled by generals and emperors so that they could become the momentary masters of a fraction of a dot. He spoke of our planet being a very small stage in a vast cosmic arena. And he arrived, gently, at the conclusion that this realization should encourage us to deal more kindly with one another and to preserve and cherish the pale blue, the only home we've ever known. It's worth sitting with this image, and not just as a humbling one. Yes, it's humbling, but it's also clarifying. From 6 billion kilometers away, there are no borders on that dot. There are no warring nations, no divided neighborhoods, no one richer or poorer or more important than anyone else. From that distance, all the divisions we spend so much energy defending evaporate. What you see is simply life. Life against an incomprehensible backdrop of empty space. And life, human life, becomes something to be cherished simply because it exists at all. Not because it achieved something, not because it was productive, just because it's here on this fragile, improbable, beautiful dot. Part 10. The longevity of light. Right now, there's a photon of light that has been traveling for 380,000 years. It was released when the universe was still young, 380,000 years after the Big Bang, when the cosmos cooled enough for atoms to form and light to travel freely for the first time. That light is still traveling. It's all around us. In fact, we can detect it as what scientists call the cosmic microwave background, or CMB. If you had the right equipment, you could tune to it like a radio station. It's the oldest light in the universe, and it fills the cosmos uniformly in every direction. We are bathed in ancient light. The universe is older than it looks, and it looks ancient. But let's talk about other kinds of light. The light from stars. When you look at the night sky, you are not seeing stars as they are. You are seeing them as they were, because light travels at a finite speed, and the distances are enormous. The moon you see is the moon as it was about 1.3 seconds ago. The sun is 8 minutes in the past. The nearest star besides our sun, Proxima Centauri, you see as it was 4.24 years ago. The Andromeda Galaxy, visible as a faint smudge with the naked eye on a dark night, appears to us as it was 2.5 million years ago. You don't need a time machine. You just need a clear sky. Every star is a message from the past. Every photon of starlight that enters your eye has been traveling, in some cases for thousands or millions of years, through the emptiness of space, to reach precisely that point in time and space where your eye was waiting. Isn't that extraordinary? Isn't it almost like the universe is sending you a letter? A very, very long letter from very, very far away? The relaxing thing about this is that the universe is patient. Light doesn't get tired. It doesn't check the clock. It doesn't wonder if it should have taken a different path. It just travels at 300,000 kilometers per second in a perfectly straight line for as long as it takes. No hurry, no doubt, just light moving through space, doing the only thing it knows how to do. There's a kind of peace in that. Part 11. Neutron stars and the strangeness of existing. Let's visit something wild for a moment. Something that makes Earth feel like a luxury resort by comparison. When a star much more massive than our sun reaches the end of its life, it explodes in a supernova. What's left behind? If the star was massive enough but not massive enough to become a black hole, is a neutron star. A neutron star is one of the strangest objects in the known universe. It has the mass of about 1 to 2 suns, packed into a sphere roughly 20 kilometers across, about the size of a city. If you could take a teaspoon of neutron star material and bring it to Earth, it would weigh about 1 billion tons. A single teaspoon. The gravity on the surface of a neutron star is so intense that if you fell toward one from a height of 1 meter, you would hit the surface at about 2,000 kilometers per second. Some neutron stars spin very fast. These are called pulsars, and they emit beams of radio waves that sweep through space like a lighthouse. The fastest pulsars spin hundreds of times per second. The fastest known one rotates more than 700 times per second. That's a star the mass of the Sun, the size of a city, spinning over 700 times per second. There are exotic theoretical states of matter inside neutron stars that we may not have the physics to fully describe yet. The core of a neutron star might contain a state of matter, quark-gluon plasma, perhaps, that hasn't existed freely in the universe since the first microseconds after the Big Bang. You are on a planet where nothing spins that fast, where gravity is gentle enough to let you walk and breathe, where the temperature range in which you live spans perhaps 100 degrees Celsius on the extreme ends. You are on a planet precisely hospitable to your form of life, orbiting a stable star in a quiet region of the galaxy. The universe contains neutron stars that would obliterate you in ways that defy description. And you are here, in this gentle corner, with breathable air and liquid water and a sky that turns pink at sunset. That's not nothing. That's an almost impossible gift. Part 12. The Scale of Galaxies. We've mentioned galaxies a few times. Let's really sit with what they are. A galaxy is a gravitationally bound system of stars, stellar remnants, interstellar gas and dust, and dark matter. Our galaxy, the Milky Way, is estimated to contain somewhere between 100 and 400 billion stars. Read that again. 100 to 400 billion stars in one galaxy. And the Milky Way is not particularly large as galaxies go. It's a barred spiral galaxy about 100,000 light-years in diameter. Our solar system is located about 26,000 light-years from the galactic center, in a fairly quiet region between two of the spiral arms. If you were to drive across the Milky Way at highway speed, 60 miles per hour, it would take you roughly 600 billion years. The universe isn't old enough yet. You'd still be driving if you'd started at the Big Bang. There are galaxies far larger than the Milky Way. IC 1101, one of the largest known galaxies, is roughly 60 times the diameter of the Milky Way. If it replaced our galaxy, it would nearly reach the Andromeda Galaxy, our nearest large neighbor. And then there are galaxy clusters, groups of hundreds or thousands of galaxies, bound together by gravity and dark matter, forming structures that can span millions of light years. And above that, superclusters. The Milky Way is part of a supercluster called Laniakea, which contains roughly 100,000 galaxies and spans 520 million light-years. And above that, filaments and voids. The large-scale structure of the universe looks, at the very largest scales, like a cosmic web, bright threads and sheets where galaxies cluster, surrounding vast dark voids that contain almost nothing. It looks, somewhat disconcertingly, like a neural network, or a root system, or a soap bubble foam. The universe has structure at every scale, from the quantum to the cosmological. And sitting somewhere in that structure, on a pale blue dot orbiting an ordinary star in a quiet corner of a middling galaxy, is you. Infinitely small, and somehow staggeringly significant, simply by virtue of being conscious. Simply by virtue of being able to see it all and ask, why? Part 13. The long future of the universe. We've talked a lot about the past. Let's take a breath and look forward. The universe has a future, and parts of it are genuinely beautiful. For the next several billion years, the story of the universe continues much as it has. Stars will be born and die. Galaxies will collide and merge. The Milky Way and Andromeda will collide in about 4.5 billion years, though it will be a slow, sprawling dance rather than a violent crash. Our sun will eventually swell into a red giant, engulfing the inner planets, and then shrink into a white dwarf, a dense, fading ember of its former self. But the universe goes on for much, much longer than that. For the next few trillion years, far beyond any human comprehensible scale, the universe continues making stars, though at a decreasing rate. Eventually, all the gas available for star formation will be used up, and no new stars will form. The stars that remain will slowly burn out, one by one, over billions and trillions of years. After that, after a period of time so vast, it makes the current age of the universe look like an eye blink. Even the longest-lived red dwarfs will eventually cool and die. Black holes will dominate the universe, and eventually even they will slowly, so slowly, evaporate through a process called Hawking radiation, radiating away over timescales of 10 to the power of 100 years. After that, the universe will be cold and dark and empty. This is called the heat death, the final state of maximum entropy, where no more work can be extracted from any system, where nothing can happen anymore. Now, that sounds bleak, and I want to be honest. It is, in a certain light, a melancholy fact. But here's where the perspective shift comes in. We are alive in the best possible cosmic moment. The universe is still young. Stars are still being born. Energy is plentiful. The cosmos is still dynamic and strange and full of potential. The complexity that arose from the Big Bang is still unfolding, still becoming. Life, wherever it exists, is possible right now in a way that it won't always be. You are not late to the party. You are here, in the richest, most energetic, most structurally complex era the universe has ever known. The lights are on. The fire is burning. The music is playing. This is the golden age of the cosmos, and you're in it. Part 14, What We Don't Know. Here is a partial list of things we don't know about the universe. We don't know what dark matter is. We don't know what dark energy is. We don't know if the universe is infinite or finite. We don't know what, if anything, preceded the Big Bang. We don't know whether the laws of physics are the same throughout the entire universe, or only in our observable corner of it. We don't know whether there are other universes. We don't know why there is more matter than antimatter in the observable universe, a slight asymmetry that allowed everything we see to exist, but whose origin remains mysterious. We don't know whether life exists elsewhere in the universe. We have not found it. We haven't proven it doesn't exist either. We don't know whether there are other forms of intelligence in the cosmos, whether we are alone or surrounded by others we haven't yet been able to hear. We don't fully understand what happens inside black holes. We don't understand why the constants of nature, things like the strength of gravity, the charge of an electron, the speed of light, have the exact values they do, values that turn out to be precisely tuned for the existence of complex structures like stars, planets, and life. We don't fully understand consciousness, what it is, why it exists, how physical processes in a brain give rise to the subjective experience of being something. This is sometimes called the hard problem of consciousness, and it remains completely open. There is no scientific consensus on why it feels like something to be alive. Yet here we are, feeling. We don't know whether mathematics is discovered or invented, whether the equations that describe reality are features of reality itself or constructions of human minds, whether an alien civilization with a completely different cognitive architecture would arrive at the same mathematics we use, or something unrecognizably different. We don't know what sleep is for, not fully. We've known that animals need it. We know that the brain does important work during sleep. But the deepest functions of sleep remain mysterious. The most universal experience of every animal with a brain, every single night of its life, is not yet fully explained. This is not a list of failures. This is a list of open invitations. The universe is still offering itself to be known. These are not closed doors, they're open ones, through which brilliant and curious people are already walking every day. Future generations will know things we can't yet imagine, about the nature of reality, about the origin of the cosmos, about whether we are alone, about the nature of mind. And that is not frightening. That's exciting. The story isn't finished. The mystery is still alive. The universe still has secrets. And isn't that wonderful? The universe doesn't ask that you solve these mysteries. It doesn't require your participation in the great unresolved questions of physics and cosmology. But it does offer them to you, freely, as gifts, as windows, as places to let your mind go when the ordinary world feels too small. When the pressure of daily life becomes oppressive, sometimes the best thing you can do is look up, literally or figuratively, and remember that the greatest minds in human history have spent their lives working on questions that remain open, and that those open questions are not a sign of failure. They are the shape of a universe that is always larger than our understanding of it. A universe that always has more to give. Part 15. The lucky numbers, constants that make life possible. Here's one of the most quietly mind-blowing facts in all of physics. The universe has a set of fundamental constants, numbers that describe how forces behave, how particles interact, how energy flows. Things like the gravitational constant, the fine structure constant, the speed of light, the mass of the electron. These constants are not derived from deeper principles. As far as we know, they just are what they are. We measure them. We don't derive them from first principles. And here's the thing. If many of these constants were even slightly different, by small percentages in some cases, by fractions of a percent in others, the universe would be radically different. In most cases, it would be a universe incapable of supporting stars, planets, chemistry, or life. If gravity were slightly stronger, stars would burn out in millions of years rather than billions. Not enough time for life to develop. If the strong nuclear force were slightly weaker, nuclei wouldn't hold together, and there would be no atoms beyond hydrogen. If the electromagnetic force were slightly different, chemistry, as we know it, wouldn't work. The universe seems, in some sense, tuned for the existence of complexity in life. Now, this doesn't necessarily mean it was designed. There are several possible explanations, from the multiverse hypothesis. If there are infinitely many universes with different constants, it's inevitable that some would support life. To the anthropic principle, we can only find ourselves in a universe compatible with our existence. So naturally, this universe seems compatible to possibilities we haven't yet imagined. But whatever the explanation, the effect is the same. The universe you live in is a universe where life is possible, where atoms can form and molecules can organize and cells can divide and hearts can beat and minds can wonder. You are the product of an extraordinary cosmic coincidence, or an extraordinary cosmic design, or something stranger than either. And the universe seems to have arranged itself, in every measurable way, to make you possible. How's that for a Valentine? Part 16. The silence of space and what it offers us. There is no sound in space. Sound is a pressure wave. It travels by compressing and expanding a medium, like air or water. In the near vacuum of interstellar space, there's no medium. When a star explodes in a supernova, one of the most violent events in the galaxy, the explosion is silent. It roars in every other way. It shines with the brightness of billions of suns. It releases more energy in a few seconds than the sun will release in its entire lifetime. And it is completely, utterly silent. The universe is almost entirely silent. This is a remarkable fact. The vast majority of everything that has ever happened, the birth of stars, the collision of galaxies, the slow dance of billions of worlds around billions of suns, has happened in perfect, absolute silence. And there's something immensely peaceful about that. You are on one of the tiny noise-producing islands in this vast sea of quiet. Earth is a noisy place. There's wind and rain and music and engines and voices. But step back far enough, go up far enough, and all of that fades into nothing. There is a version of the universe in which you zoom out until your planet disappears, your solar system disappears, your galaxy disappears, and what remains is silence and light. Stars blooming and fading in silence. Galaxies spinning in silence. The slow, patient expansion of space in silence. No panic, no noise, no urgency, just the steady, ancient work of the cosmos, unfolding in its own time. That silence is always there, behind everything. Even now, even in the midst of your loudest and busiest days, the silence of space is just outside the atmosphere. It's very, very close. Part 17, The Overview Effect. In 1987, philosopher Frank White coined a term for something that kept being reported by astronauts returning from space: the overview effect. When humans see the Earth from orbit for the first time, when they look out the window and see the planet hanging in the black, no boundaries, no divisions, just a vivid, beautiful, improbably alive sphere, something happens to them cognitively and emotionally. They feel a shift in perspective. They feel a sense of connection to other humans, to all life on Earth, to the cosmos. They feel, almost universally, that the things that divide us seem absurd from that vantage point. They feel a powerful desire to protect this fragile world. Many astronauts have described weeping. Many have described feeling as though some fundamental truth had finally become visible to them, something they knew intellectually but could now feel. Edgar Mitchell, who walked on the moon during Apollo 14, described looking out the window at Earth and having a sudden, overwhelming sense that the universe was in some way conscious, that everything was connected, that the experience of being alive was part of something vast and meaningful. He described it as an instant global consciousness. Ron Garan, a NASA astronaut, described looking down and simultaneously feeling profound beauty and profound sadness, seeing how gorgeous the planet is, and knowing the suffering happening on it. You and I cannot orbit the Earth, at least not today, not easily. But we can practice a version of the overview effect from right here. We can mentally zoom out. We can hold the image of the pale blue dot in our minds. We can remember that from orbit, the borders disappear, and what remains is life on a small, warm world. The next time you feel the urge to divide the world into us and them, the next time you feel your problems growing to fill the entire sky, try to zoom out. Not to dismiss what you're feeling, but to put it in a context that might gently loosen its grip. From high enough up, we are all on the same team. We always were. The overview effect points to something that the contemplative traditions of many cultures have been saying for thousands of years, that a certain kind of perspective shift, achieved through meditation, prayer, philosophy, or in the case of astronauts, literally leaving the planet, reveals a truth that is normally hidden by the noise of ordinary life. The truth that separation is, in some deep sense, an illusion. That beneath the diversity and conflict of human experience, there is a fundamental unity. We are all life, on one world, under one sky. Astronaut Rusty Schweickart, who flew on Apollo 9 in 1969, described the experience of looking down at Earth during a spacewalk. He wrote that you think about what you personally are responsible for. You think of the billions of people down there. You think about what history is. And you realize that history has brought you up here, somehow, to this place, to this perspective, and you want to do something with that. You want to translate it. That impulse, to translate the perspective, to bring something back from the overview, is one of the most human things imaginable. We have always been creatures who seek higher ground, literally and figuratively, who climb mountains to see further, who build towers, who launch telescopes into orbit, who ask, from whatever height we can manage, What does the world look like from here? The answer, again and again, is the same. It looks beautiful. It looks fragile. It looks like something worth protecting. And it looks like home. You don't need to go to orbit to feel this. You can feel a version of it on a clear night, lying on your back in the dark, watching the stars wheel overhead. You can feel it when you look at photographs from the Hubble Space Telescope and contemplate what you're seeing. You can feel it when you read about the size and age of the cosmos and let that information actually land. The overview is available to you. It always has been. It just requires a few minutes of quiet and willingness to look. Part 18. Water, Life, and the Gift of Rarity. Water is strange. Most substances are denser as solids than as liquids, which means most things sink when they freeze. Ice doesn't. Ice floats. And this seemingly minor quirk is one of the reasons life exists on Earth. If ice sank, then in winter, the bottom of lakes and oceans would freeze first and keep freezing from the bottom up. Life in those waters would be crushed and frozen. Instead, because ice floats, it forms an insulating layer on the surface, protecting liquid water below and all the life within it throughout the winter. Water also has an unusually high specific heat capacity. It takes a lot of energy to heat it up, and it releases that energy slowly. This is why the oceans act as a thermostat for the planet, buffering temperature swings and making Earth's climate relatively stable over geological timescales. Water is a universal solvent. It dissolves more substances than almost any other liquid, making it an ideal medium for the complex chemistry of life. Water has a very high surface tension, allowing capillary action, the way water climbs up through thin tubes, like the vascular systems of plants, defying gravity. Water does almost everything right. It is, as far as we know, irreplaceable for life as we understand it. And Earth is absolutely covered in it. 71% of the surface is ocean, and the planet's total water content includes not just the oceans but ice caps, groundwater, rivers, lakes, and the water bound up in minerals deep in the crust. We live on a water world, a rare, perhaps unique configuration in our solar system, and we mostly take it completely for granted. The next time you drink a glass of water, something our bodies need to do many times a day just to keep functioning. Consider what that glass contains. Ancient water, much of it. Water that has cycled through clouds and oceans and rivers and ice for billions of years. Water that might once have passed through a dinosaur or a trilobite, or the first photosynthesizing organism that slowly oxygenated the atmosphere. Water that is now, briefly, yours, before it returns to the cycle. Even the most ordinary things, seen with the right eyes, are extraordinary. Part 19. The Moon and its Quiet Influence. Our moon is unusual. Most moons in the solar system are small compared to their host planets. Our moon is large relative to Earth, so large, in fact, that some astronomers classify the Earth-Moon system as a double planet rather than a planet with a satellite. The Moon is about 27% the diameter of Earth, which makes it, relative to its host, the largest moon in the solar system. Charon, Pluto's moon, is proportionally similar, but Pluto is now classified as a dwarf planet. How do we get such a large moon? The leading hypothesis, supported by strong evidence, is the giant impact hypothesis. About 4.5 billion years ago, a Mars-sized body called Theia collided with the early Earth in a glancing blow. The impact was catastrophic. Earth was largely vaporized, and the debris cloud eventually coalesced into the moon. But what does the moon do for us? Quite a lot, it turns out. The moon stabilizes Earth's axial tilt. Our planet rotates on an axis tilted at about 23.5 degrees. This tilt is what gives us seasons. Without the moon's gravitational stabilization, that tilt could vary wildly over time, from nearly 0 degrees, no seasons, but very different climate patterns, to as much as 85 degrees, devastating seasonal extremes. This stability has been crucial for the long-term habitability of the planet. The moon drives the tides. This might seem like a minor thing, but tidal zones, the intertidal areas that are alternately submerged and exposed, are some of the most biologically rich environments on Earth. Some scientists believe that tidal pools played a crucial role in the evolution of complex life, providing environments where chemistry could concentrate and react. The moon is slowly receding. Every year, it moves about 3.8 centimeters farther from Earth. Early in Earth's history, it was much closer, and tides would have been dramatically stronger. As it has moved away, the Earth's rotation has slowed. Days on early Earth were only about 6 hours long. The moon has gently, patiently, over billions of years, slowed our world to its current comfortable 24-hour day. And then there's the moonlight itself. On a clear night, the full moon is bright enough to cast shadows. It has lit the way for hunters and travelers for as long as humans have existed. It has inspired poetry and mythology and song across every culture on Earth. It has been our companion in the dark. Whatever was lost in that collision with Theia 4.5 billion years ago, something extraordinary was gained. A guardian, a timekeeper, a tidal engine, a nightlight for a small blue planet. Part 20. The Fermi Paradox and the Gift of Uncertainty. In the 1950s, physicist Enrico Fermi posed a question that has haunted astronomers and philosophers ever since. If the universe is so vast and so old, and if the conditions for life seem relatively common, then where is everybody? This is the Fermi Paradox. The galaxy is 13.6 billion years old. Our solar system is 4.6 billion years old. If technological civilizations arise regularly, some of them should have had billions of years of head start on us. Even at a tiny fraction of the speed of light, they should have had time to colonize or at least contact every corner of the galaxy many times over. And yet we see no signs of them. We hear no signals. We find no artifacts. The sky is silent. There are many proposed solutions. Maybe intelligence is much rarer than we think. Maybe civilizations tend to destroy themselves before they can expand. Maybe they're there, but we're not looking in the right way. Maybe they're deliberately silent. Maybe the distances are simply too vast for any kind of contact to be practically possible. Maybe we are, in fact, alone. We don't know. And for our purposes tonight, the uncertainty itself is the interesting thing. Before we get to the comfort in the uncertainty, let's look at some of the proposed solutions, because they each carry their own kind of wonder. There's the rare Earth hypothesis, the idea that the combination of conditions that allowed complex life to arise on Earth was extraordinarily unlikely, perhaps even unique. A large moon to stabilize axial tilt, a gas giant like Jupiter in the outer solar system, acting as a gravitational shield, catching many comets and asteroids that might otherwise bombard the inner planets. A star that is stable, not prone to violent flares, in a relatively quiet region of the galaxy. Plate tectonics that cycle carbon and regulate climate over geological time. An oxygen-rich atmosphere created by billions of years of photosynthesis. A planetary size that allows a magnetic field strong enough to protect the surface from radiation. Each of these features, alone, is not unique. But all of them together, on a single world, that combination might be extraordinarily rare. And if it is, if Earth is in some sense a cosmic fluke, that doesn't make it sad. It makes it precious. There's the Great Filter hypothesis, the idea that something tends to stop civilizations from expanding into the cosmos. Maybe it's the origin of life itself, very hard. Maybe it's the development of intelligence, very rare. Maybe it's the development of technology, rare. Or maybe the filter is ahead of us, some threshold that technological civilizations tend not to survive. Most people prefer the filter to be behind us. Most people prefer to think that we've already passed the hardest test. that the miracle of our existence means we're through the narrow gate and clear skies lie ahead. And then there's the simplest answer. Maybe we just haven't been looking long enough, or in the right way. We've only been listening for radio signals from other civilizations for about 60 years, a cosmic eye blink. Perhaps there are signals. Perhaps they've been there all along, encoded in frequencies we haven't thought to tune into, or carried in ways we don't yet have the technology to detect. Perhaps someone is listening to us right now, listening to the radio waves that have been leaking off our planet for a century, watching them spread outward at the speed of light, reaching worlds we've never heard of. The first radio transmissions from Earth, Marconi's signals, the BBC's early broadcasts, are now about 120 light-years out. That's a sphere of radio frequency information centered on Earth, expanding at the speed of light, growing larger every year. Any civilization within 120 light-years with the right equipment could, in principle, know that something is transmitting from this direction. We are not silent. We have been announcing ourselves, unintentionally, for 100 years. Whether anyone is receiving that message, we don't know. The answer to that question is one of the most important questions in the history of our species. If we are alone, if life, and especially intelligent life, is extraordinarily rare, then the weight of the cosmos's consciousness rests on us. Everything the universe will ever know about itself, it knows through us. Our joy and curiosity and love are the universe's way of experiencing joy and curiosity and love. That's not a burden, that's a calling. If we are not alone, if the universe is, in fact, teeming with life in forms we haven't yet detected, then we are part of a vast, interconnected community of consciousness, separated by distance, but not by the fact of existence. Somewhere out there, something is alive, looking at a sky full of stars, asking the same questions we are. Either way, there is something beautiful waiting at the end of that question. Part 21. Coming Home. The universe inside you. We started with the fact that the atoms in your body are ancient. Let's end there too, but from a different angle. The human brain contains about 86 billion neurons. Each neuron can form thousands of connections with other neurons. The number of possible configurations of connections in a single human brain is estimated to exceed the number of atoms in the observable universe. You are, in some ways, as complex as the cosmos itself. The universe spent 13.8 billion years building the conditions for you to exist, forging elements in stars, distributing them in supernovae, forming planets, generating oceans, nurturing life through billions of years of evolution. And what it built, ultimately, was a structure capable of turning around and contemplating itself. You are the universe looking at itself. You are the cosmos asking what it is. You are made of ancient stardust, animated by billions of years of biological experimentation, and you can sit in the dark on a clear night and feel the immensity of it all, and feel small, and feel wonder. The universe does not require anything of you. It does not demand productivity or meaning-making or understanding. It simply expands, slowly, in every direction, patient and ancient and unimaginably vast. But it made you, and in making you, it made something capable of awe, something capable of love, something capable of sitting with a cup of tea on a quiet night and looking up at the stars and feeling, for just a moment, completely at peace. That is not accidental. That is what the universe does. It makes things that can feel the miracle of existing. You don't have to solve the Fermi paradox. You don't have to understand dark energy. You don't have to reconcile quantum mechanics with general relativity. You don't have to figure out what came before the Big Bang. You just have to be here, in this moment, on this pale blue dot, breathing air that was made by ancient bacteria, drinking water that cycled through oceans millions of years before you were born, under a sky full of stars that are, as you look at them, sending you light from the past. You are home. You have always been home. The universe is your home. Conclusion: the most relaxing fact of all. Here is the most relaxing fact about the universe that I know. The universe doesn't need you to hold it together. The stars don't need you to keep burning. The galaxies don't need you to keep spiraling. The laws of physics will continue operating whether you figure them out or not. The cosmos has been doing this for 13.8 billion years without your help, and it will continue for billions more. You can let go, not of your life, not of the people you love and the work you care about and the experiences that fill your days, but of the weight, of the sense that everything depends on you, of the belief that if you stop vigilantly holding everything together, it will all collapse. It won't. The universe is not fragile. It is vast and ancient and patient, and it will be fine. And knowing that, really knowing that, feeling it in your chest, creates space, room to breathe, room to simply be present in this vanishingly brief moment you've been given, on this improbable planet, in this extraordinary era. We've traveled a long way tonight. We started with your atoms and their ancient origins. We visited the emptiness of space and discovered that emptiness is full of wonder. We bent time and found it softer than we usually allow ourselves to believe. We watched stars being born and died and born again. We stood next to our extraordinary, ordinary sun. We rode with Voyager 1 into the dark. We compressed 13.8 billion years into a single calendar year and found ourselves in the final 10 seconds of December 31st, alive and wondering. We touched neutron stars and marveled that we're not on one. We stood at the edge of the known universe and peered at the unknown. We held the pale blue dot in our minds and felt the borders dissolve. We heard the ancient light of the cosmic microwave background and understood that the universe has been sending signals since the very beginning. We floated in the overview effect and felt, for a moment, the profound fact of being alive on one world under one sky. We wondered whether we are alone, and found that either answer leads somewhere beautiful. And now we return, not to a smaller world. The world is still vast and full and extraordinary, but to a world we might see a little differently, a little more gently, a little more gratefully. You are made of stars. You are held by gravity, warmed by a fusion engine 93 million miles away, wrapped in a thin layer of oxygen generated by ancient life. You are, right now, living inside one of the most sophisticated information processing structures the universe has ever created, your own mind. And you are, right now, being carried through the Milky Way at about 828,000 kilometers per hour around the galactic center, in a journey that takes 225 million years to complete. You've done this before. You'll do it again. The galaxy is your vehicle, and it's one of the most beautiful things in existence. There are, by conservative estimates, hundreds of billions of planets in our galaxy alone. Of those, some unknown number have conditions that could support life. Of those, some may already have life. Of those, some may have had life for far longer than Earth. And somewhere, on some world we've never seen, under a sun we've never named, perhaps something is alive that has never heard of us, has never known we exist, and is looking up at its own sky and feeling its own version of wonder. We are not alone in the universe, not because we know of others, we don't, not yet, but because the impulse to look up and wonder, to ask questions about our origins and our place in the cosmos, seems like something the universe tends to produce. We are not an accident or an aberration. We are the universe doing what it does, organizing matter into ever greater complexity, ever greater awareness, ever greater capacity to feel. And what it has felt, through you, tonight, if even a fraction of these ideas has settled into your chest and loosened something there, is wonder. And wonder, I believe, is the opposite of anxiety. You cannot be full of wonder and full of dread at the same time. Wonder opens you up. It makes you large. It reminds you that you are not trapped in your life. You are on an adventure so vast and strange and beautiful that language barely scratches its surface. The universe is large and old and full of things we don't understand. And you are small and brief and, in all the ways that matter, absolutely extraordinary. Take a breath. Look up when you can. And remember, the light from those stars has been traveling for a very long time just to reach you tonight. You were worth the wait.